Welcome to homework.
Before we begin this problem, make sure that you have completed question 63 in this chapter. This will allow you to have the correct values to fill in the Born-Haber cycle. Remember that when we're doing a Born-Haber cycle, we order on the page from top to bottom, highest enthalpy to lowest enthalpy. Let's begin with the natural state of lithium and fluorine. This is going to be towards the bottom of the page, but not the complete bottom. Recall that in its natural state, lithium will be a solid, and fluorine will be a diatomic gas. Remember that we have to have the fluorine because we want to end up at the very end with lithium fluoride as an ionic compound. In this ionic compound, we only have one fluorine, so we want to make sure we have one fluorine throughout our cycle. Let's start by taking step 1 of the Born-Haber cycle, which is to turn lithium from a solid into a gas. The change in energy for this step is going to be the heat of sublimation of lithium, which was given to us in problem 63. This is equal to positive 159.4 kilojoules per mole. Remember when we're drawing out our Born-Haber cycle that we want arrows to point upwards to indicate that we have a positive value. The second step of this cycle is to turn lithium from a gas to an ion. Recall that when lithium loses an electron, the change in energy is going to be known as the ionization energy. This was given to us also as positive 520 kilojoules per mole. Let's move on to the third step of this cycle. The third step of the cycle is to turn fluorine from a diatomic gas to a monoatomic gas. It's important to note that the change in energy in this step is going to be equal to half the bond dissociation energy of fluorine. The reason that it's going to be equal to half of the bond dissociation energy is because bond dissociation energy is given for 1 mole of diatomic fluorine. However, we start with half a mole because, again, we want to end up with having 1 mole of fluorine in total. So we have the value that we were given, which is 158 kilojoules per mole. So the change in energy in this step is going to be equal to 79 kilojoules per mole. Now that fluorine has been turned into a monoatomic gas, we can now turn it into its ion. The change in energy for this step is going to be equal to the electron affinity of fluorine. This was given to us in 63 as well. The electron affinity is equal to negative 328 kilojoules per mole. The next step is to take these two ions and to turn them into an ionic compound. When this occurs, energy is released, and the change in energy is going to be equal to negative lattice energy. This was given to us in the table 6.3. The value is negative 1036 kilojoules per mole. Finally, we simply have to fill in the heat of formation, which is the formation of the ionic solid from the elements in their natural form. And this is going to be equal to the sum of all of the values that we had before. You should have answered this in question 63. However, if you didn't, we can add up all the values that we have. This will give us the heat of formation, and that is equal to negative 606 kilojoules per mole. This is what the final Bohr-Haber cycle will look like.